Okay, in this section we're going to talk about some ways to prove that triangles are congruent. There's a bunch of ways, and we'll talk about 3 of them in this section. The first one is the side-side-side postulate, or SSS. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So here I've got these 3 lines, one's in red, one's in purple, and one's in blue. And as long as I keep making triangles from these 3 lines, they are always going to end up being the same size, and with the same angle, so they'll be congruent. Now, if you don't believe me, I'm going to go to the National Library of Virtual Manipulatives. You can look this up online. And what they've done here is they've given me these 3 lines in red that I can connect together, and they've given me 3 lines in blue that I can connect together. Now if I can do this. Okay, here we go. Getting there, almost. Okay. That's 1. Now these blue lines, the lines in blue are the exact same lengths. These sides, these 3 sides are the exact same length as the 3 sides from the other red lines. This is kind of tricky. Hey, there we go. So now you can see that if I rotate this, oops, I gotta flip it. Okay, if I rotate it, there we go. Oh, look at that. It's a perfect match. So having 3 sides the same means that the triangles are always going to be congruent. No matter how you put the sides together, they're going to end up being congruent triangles. Okay, next one is the side angle side. And just like it says, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So the order here matters. It has to be the side and then that angle and then the next side. If those pieces, those parts, are congruent to the parts of another triangle, then you've got congruent triangles. Okay, let's go back here. Let's look at side angle side. So they give me a side here. They give me an angle. So this angle is always going to stay the same. So let me put it over here. I'll put this side right there, up to that angle. I'll put this side right here, and up to that angle. That gives me that triangle. Okay. In blue here, I've got the same thing, the same angle, and the same 2 sides. So if I put those together, I've got that. Let me rotate this a little bit more here. And there it is. Why isn't it blinking? Gotta get it just right. This is picky. Nope. Well, it looks the same. Okay, I'm saying they're congruent. So that's the side angle side postulate. Then, angle side angle. Again, if 2 angles and the included side are congruent to 2 angles and the included side of another, then the triangles are congruent. Okay, so let me go back real quick here. Well, actually, this is not going to be quick. I'll tell you what. You can try this at home. Go search for National Library of Virtual Manipulatives, or I'll put the link up on my website, and you can try this at home. Okay, so let's go on. Let's use this now. We've got the side angle side, side side side, and now we've got this one, angle side angle. So just remember those in order. If you've got all three sides, congruent to all three sides, or if you've got the side, the angle of the side, congruent to another side angle side, or this one, if you've got an angle side angle, congruent to another angle side angle, then you've got congruent triangles. All right, enough talking. Let's prove it now. Let's prove here that triangle ACM is congruent to BCM. So I've got ACM. I'm going to try to prove that that triangle is congruent to triangle BCM. Okay, so we're going to use one of those three postulates that we just talked about. So we either have to find three sides that are congruent, we have to find a sine angle side, or we have to find an angle side angle. Now, you look at this, you look at your given information, this is telling us a lot. A midpoint, that means I'm going to have two congruent segments. I've got perpendicular lines, that means I'm going to have congruent adjacent angles. So what I see so far is I see that AM I can show that is congruent to MB. So let me do that first. Okay. So we'll start here. There are statements. And our reasons. Okay. First, let's put the midpoint first. M is midpoint. Of AB. I kind of ran out of room. Okay, if M is the midpoint of AB, then that gives us AM is congruent to MB. Because that's what a midpoint does. That's the definition of a midpoint. It cuts it up into two congruent segments. Okay, so I've got that one. I've got these sides being congruent to each other. Now let's talk about these angles. I want to show that those angles are congruent to each other, and we can use our perpendicular lines. So for my third step, I'm just going to state that. It's given information again. If you already stated this in the first line, that's fine. But AB is perpendicular to MC. That's given. Okay. Now we can say that angle AMC is congruent to angle BMC because perpendicular lines form congruent adjacent angles. Okay, so that gives us a side and an angle. So to round this out, we either need to get this angle out here to give us an angle side angle, or we need to get this side here to give us a side angle side. Well, as it turns out, they share this side, and this is going to help us a lot. In a lot of these proofs, if you see that two triangles share a side, that's great. We can use that. We can just simply say that CM is congruent to CM. Because we're talking about the line segment CM of this triangle, and then we're talking about the line segment CM of this triangle. I know it's the same line segment, but we need to state it so we have that piece of the puzzle. We have that side in the side angle side. And why would something be congruent to something else? Just like looking in the mirror. It's the reflexive property. Okay, so we've got it. we've got our side, we've got our angle, and we've got our side. So we can state that, we can finally state that triangle ACM is congruent to triangle VCM. Because we found a side and an angle and a side that's congruent to the other side angle side, and that's it. It's the side angle side postulate. We are good to go. All right. I hope that helps.